So, hi everyone, good evening, and welcome to this session number 2A for fifth edition of International Conference on Smart Friends in Computing and Communication. Uh, we have with us the session chair for this session, Dr. Pancham Shukla, who is based in United Kingdom. And just to brief about him, he holds a PhD degree in Electrical and Electronics Engineering from Imperial College London, MPhil in Electronics and Electrical from University of Surrey, Glasgow, UK, Masters in Electronics and Computer Engineering and Bachelors in uh, Electronics Engineering from Sardar Patel University, India. He is a senior lecturer in Communication Technology and Mathematics at School of Computing and Digital Media at London Metropolitan University. He is also a course leader for Computer Systems Engineering and Robotics B Engineering and Electronics and Internet of Things B Engineering. Dr. Shukla is also the Vice Chair of Research Student Progress Group and PhD degrees. He is recipient of Vice Chancellor's Award for Outstanding Contribution to Learning and Teaching, as well as Student Union's Award as an Outstanding Member of Academic Staff. Dr. Shukla has supervised a broad range of projects and published papers in signal and image processing, electronics and communication systems. In recent years, Dr. Shukla has been focusing on applications of signal and image processing in computer vision, machine learning, robotics, Internet of Things, and cybersecurity. He has organized conferences and has served as a technical session chair along with reviewing many international conference and journal papers. Prior to joining London Met in 2007, Dr. Shukla worked as a research fellow in the Applied Digital Signal and Image Processing Center at University of Lancashire and as a research associate in Communication and Signal Processing CSP Group at Imperial College London. We are proud to be associated with you, Dr. Shukla, and we welcome you to this session number 2A. Over to you for your opening remarks, Dr. Shukla.
Thank you, Amit, and thank you all the participants. I'm delighted and humbled by your kind words. I now welcome all the participants to the Smart Trends of Computing and Communication, which is the fifth international conference. It is supposed to be in Las Vegas, Nevada, but we are in a virtual room, so we need to imagine as if we are in US Las Vegas. So once we are ready, maybe we can start with the
Yeah, we are ready. So let's start with the first presentation of the session. That is design and implementation of a machine learning based technique to detect unipolar and bipolar depression using motor activity data by Praveen Manoj Singh. So is Praveen here?
Yes, sir, I'm here.
Yeah, please go ahead with your presentation. You
Okay.
have 12 minutes for the presentation and then 3 minutes for question and answer. So total of 15
Okay.
minutes.
Sir, can I share my screen, sir?
Yeah, you can.
Sir, is my screen visible?
Yes, it is. It is.
Okay. Good evening, everyone. My name is Praveen Manoj Singh, and the topic of my presentation is design and implementation of machine learning based technique to detect unipolar and bipolar depression using motor activity data. These are the list of the topics which we will be seeing throughout the presentation. Mental health disorder are a common neurological disorder in which most of the humans face this problem all around the world. And it is estimated that more than 350 million people have been suffering from depression like at the present situation, or they have faced it in the past. So it becomes a major problem which everyone faces in their life at some point or the other. As per the analysis released by World Health Organization, it has been said that by the year 2024, a large amount of population will be exposed to some kind of mental disorder. And in this mental disorder, depressive disorder are one of the most common disorders which people face, and they have a major contribution in this burden. So, by seeing the level of threat this depressive disorder poses to human race, it is the need of hour to come united and to implement or to design a method to a design a method for proper diagnosis of such kind of mental disorders. So the researchers around the globe are working to arrive at an optimal solution for diagnosis of mental disorders. Currently, and at now, like there are two major types of mood disorders: major depressive disorder, which is commonly known as unipolar depression, and bipolar disorder. So currently, at present situation, the diagnosis of unipolar depression and bipolar depression, that is MDD and BD, is done using clinical criteria, which is outlined in the major classificatory system. So at present, what happens is, whenever a patient, he or she comes to a hospital for diagnosis of any kind of depression, the clinical expert which checks them, basically what they do is they perform some counseling session onto the patient. So what happens is, as per the classificatory system, they have a particular set of questionnaires, they have a particular set of conditions, and in the counseling, what happens is they put forward this set of questions, they put forward this set of condition in front of the patient, and then on the basis of their response, how do they respond to those questions, how do they respond to such condition, they give a particular score to that question for that particular patient. So at the end, when all the questions and all the conditions are put forward to them, and on the basis of their response, a total score is obtained. And on the basis of their score, it is finally classified whether this patient belongs to MDD or he or she is suffering from bipolar depression. So now the major challenge here is that unipolar depression and bipolar depression, they have a lot of common symptoms here. So due to this common symptoms, due to this overlapping of systems, it becomes very difficult to differentiate unipolar and bipolar depression. And this is the major reason, like this is the main reason why we have approach to this problem. Because let's say if a subject is suffering from unipolar depression and he gets misdiagnosed as bipolar depression, so because there are chances that he might get misdiagnosed, so it can create a lot of problem for that particular patient, because like that can cause delay in treatment, it can cause various health issues for them, because unipolar depression has a particular set of treatment by which this treatment is done, and bipolar depression, it has a particular set of depression by which the treatment is done. So if a person gets misdiagnosed, then he will be getting treatment for the other disease for which he is diagnosed. So it is very much important that he should be correctly diagnosed by the disease which he is suffering from. So, like if he or she gets misdiagnosed, then it can create increased rates of mood switching, higher treatment cost, and also lower productivity. So, it is the need, like we need to arrive at a proper solution, proper diagnosis method for this kind of problems. So, in the research which has been done in the past in this domain, the biomarkers play an important role. And in those research, biomarkers such as EEG, MRI, CT scan, they play an important role in the research which are related to this domain. So in this research, what we have done is we have taken motor activity data. So here, motor activity data of subjects suffering from unipolar depression, bipolar depression, and healthy patients, these are collected using wearable sensors. Basically, we allow the patients to wear an actigraph watch. In this actigraph watch, the wearable sensor devices are installed, and this wearable sensor devices, they are capable of collecting motor activity data. Other than the motor activity data, they are also capable of collecting blood pressure, heartbeat, and glucose level. So this data set, the repository of this whole data set is termed as depressome. And here the motor activity reading, it is recorded at an interval of every 1 minute. And here, like for every patient, the number of days for which the reading is recorded is a bit different. So what we have done is like we'll be taking uniform number of days for every patient, which we'll be discussing in the next part. So here we'll be designing a classifier with the help of depressome dataset to classify unipolar, bipolar, and healthy subjects. Now, in the past, all the major research work which were done in this domain, they were mainly focused on classifying depressed and non-depressed subjects. So what we have focused here is, because as we know that the misdiagnosis can occur, can create a lot of problems. So we have seen that no work in the past has been reported to classify subjects into unipolar and bipolar. So as we know, like if a subject is suffering from bipolar depression and he or she gets misdiagnosed, then it can create a lot of problem. So it is the need that we need to reach at an optimum and accurate way to diagnose such cases. So here, hence, this becomes our motivation to design a classifier where, with the help of which, like we'll be classifying unipolar, bipolar, and healthy subjects. In the methodology, like initially, like we have taken motor activity data in which we have total 55 subjects, in which we have 15 unipolar subjects, 8 bipolar subjects, and 32 healthy subjects. Now, the research work which is done in this field, it mainly focuses on classification of depressed and non-depressed. And here in this research, we have been focusing to design a model to classify unipolar and bipolar depressed subjects. In the initial stage, we have trained and tested our model for two-class classification of unipolar and bipolar depression. And in the later stage, we have also tested our model for three-class classification by including healthy subjects data. And the whole workflow is depicted in this flowchart. how we have approached to this problem. In the initial stage, we have been doing the data acquisition part and then followed by data pre-processing. And after that, we perform feature extraction onto it and the classification analysis is done. And then on the basis of the results which we have obtained, we have validated those results. So in data acquisition, the differential data set was collected. And in the pre-processing part, what we did is we divided the data into equal number of activity levels. As I said, that the number of data recorded for every subject, every patient is different. So what we did is we took data for 11 days for all the patient, whether it is irrespective whether the data for that patient is recorded for 2 weeks, 3 weeks, but we took data only for 11 weeks as in order to maintain uniformity in our data. So what we did is after collecting the data, we divided the data into 1 hour interval. As we know that the reading is recorded at every 1 minute, so we divided the data into 1 hour interval so that the number of samples will be increased here. And then what we did is in those motor activity data, we performed normalization onto our motor activity data. So here what we did is we have one raw data, that is the one motor activity data, and one data on which we have done normalization onto this raw data. So now we have two data, that is one normalized and one is the raw data. So we have done feature extraction in both of this data, and the statistical features were calculated in this from this data. And the list of the statistical features is shown here. We have calculated mean, standard deviation, variance, coefficient of variation, inverse coefficient of variation, kurtosis, skewness, quartile 0, quartile 1, quartile 2, quartile 3, quartile 4. These were the list of the statistical features which we have calculated. And then initially we designed random forest classifier for the classification purpose. Initially at random, we took 200 decision trees for our classification purpose. And we have trained and tested our model initially for 2-class classification, and then we moved on to 3-class classification. Now, as I previously mentioned that we have prepared two data sets. That is one that is the raw data and one is the normalized data. So initially when we calculated the features from the raw data, what we did is we gave that features to the random forest classifier, the one which is the raw data. So we saw that when the raw data is given to the classifier, the performance of the model was not up to the mark and not up to the standard which what we were expecting. So then we decided to move with the normalization data, and then we gave the features which were calculated from the normalized data to the random forest classifier. And then at the later stage, we have also designed an artificial neural network, which is a separate model. In this, we have taken 6 hidden layers, and normalized data was given to this network also. And for the validation purpose, we have calculated sensitivity, accuracy, precision, specificity, and other parameters for our models. Now, I just want to give a glimpse like how random forest classifier works. At present, in random forest classifier, it has a large number of decision trees. So what is the basic principle is random forest classifier, it basically works on the principle of ensemble learning. What happens is we have various different machine learning models. Like if I say 200 decision trees in a random forest classifier, it means we have 200 different machine learning models. Let's say we can have support vector machine, we can have linear regression, we can have k-means clustering. We have different types of different machine learning models in our 200 decision trees. And what will happen is in each decision tree, a small subset of the data will be given to that particular decision tree. So in this way, 200 decision tree will be receiving 200 different subsets of data. Now, there might be a possibility that each subset of data might have some data from the previous subset, but that is okay. That does not create any problem. So in this way, now when the classification of 200 decision tree is done, this decision tree, they work independently. They give their proper results. And now every decision tree is working independently. They are performing classification and the results is given. Now for our final result, what we do is we perform majority voting. So out of this classification result, what we have got from the 200 decision tree, we check which class has got the majority vote out of those 200 decision trees, like which class has the majority vote. So in this way, we decide like which of the class is the majority vote, that will become our actual output. That is, most of the machine learning models are voting for this class. It means that. So in this way, our random forest classifier, it works. Now we'll be seeing the results which we have got through this model, random forest classifier model. Now this is the result for 2-class classification. Like when we have performed the 2-class classification using the random forest classifier with 200 decision tree, we have got an overall accuracy of around 95%. And for bipolar case, we have got an precision of 97%. And we got a recall, that is sensitivity of 88 and specificity of 0.9. While for unipolar, we got a precision of 94% and recall of 98 and specificity of 88%. And the same model which we have when we train and test for 3-class classification, the same random forest classifier, we get an overall accuracy of around 90%. And here we see like we get a precision for bipolar class is 97% and a recall value of 80%. And for unipolar case, we get a precision of 90% and a recall value of 81%. And if we talk about the healthy subjects, we get an overall precision of 88% and a recall value of 97%. Now, as I said, we have also designed a separate artificial neural network model just to test like how it behaves on this model. So we have performed a 2-class classification onto this model, and the specification of this model are like we have used 6 hidden layers in our ANN model, and we use a batch size of 32, and the number of epochs were set as 150. So in this training and testing, we got an overall accuracy of 91%, and for bipolar case, we have got an overall precision of 93% and a recall of 80%. And in unipolar case, we have got a precision of 90% and a recall of 97%. So throughout this work, we have seen like mainly in the literature work, we have seen that the previous research work, they mainly focus on classifying depressed and non-depressed subjects. But as mentioned earlier, that the distinction between unipolar and bipolar depression is very much important to avoid misdiagnosis because it can create a lot of problem for someone's life. So it was very important to have a work like to have a proper diagnosis method for this kind of disorders. So as per the results, we can see that motor activity data has the ability to distinguish unipolar and bipolar depressed subject. And the set of statistical feature which we have calculated, they helped us in classification of subject. And the random forest classifier, it outperformed all the results which we have got as compared to the other classifiers. And also, like the conclusion part, like we can say that we have analyzed here the motor activity data of depressed and non-depressed subjects, and we designed a classifier to classify subjects into unipolar, bipolar, and healthy subjects. And at the end, we achieved an overall accuracy of around 90% for 3-class classification and 95% for 2-class classification using random forest classifier. And we can say that the developed model which we have, like the model which we have developed, when it was trained and tested on motor activity data, we can conclude that this model may have the potential utility in distinguishing unipolar and bipolar depression at their initial presentation. But however, further testing of this model is required on real-time data sets. These are the list of references which we have used throughout this research work. That's it. Thank you.
Any questions from the audience?
Looks like there is no question from the audience. I have one question, if there is no question there. Are you okay? I think still I can see the slide there.
Yeah, yes, sir.
Okay. So are you ready for the question, Praveen?
Yeah, yes, sir.
Yeah. My question was, you mentioned about the motor activity, but we are not sure from the presentation as what kind of motor activity the data you are collecting.
Yeah. So basically, sir, if I want to brief about the motor activity data, in today's time, we wear a lot of smartwatches. So basically, these smartwatches, they are capable of recording various different activities, what we do in our daily life. So motor activity data, basically, what it focuses on, like whatever physical activities which we do in our day-to-day lives, whatever physical activities, like through an example, if I say, if one person is depressed and one person is not depressed, so if we give a smartwatch to that person, to both of this person, so what will happen is a depressed person is more likely to do less physical activities as compared to a normal person. So what this motor activity does is, whenever we are involved in any kind of physical activity, that is, let's say walking, jogging, gym, whatever thing. So corresponding to every physical activity which we do, on the amount of intensity what we do, like the amount of intensity of the physical activity, a particular reading is being generated in that smartwatch. So when we do something with more force, a higher motor activity reading is recorded. Like when we do jogging, when we do any physical activity, like when we are in gym, so higher intensity of the motor activity is recorded. But
okay, yeah. I got it. So,
Yeah.
but is it specific how you will test it? Number of steps, for example, or the variation? What exactly? Okay, we understand the physical activity, but is there a specific set of things, or it's very broad?
There is nothing specific in this. Like whatever physical activities we do, whether we are just sitting and then suddenly we go to sleep. So there also a physical activity. This is also here also it is involved. So whatever force or whatever like a momentum or we can say whatever force is generated corresponding to that thing, a particular reading is being generated.
Okay, okay, I got it. And in terms of the sample, I think you have taken different kind of. There are less samples for the unipolar compared to the bipolar. Would it affect the bias of the accuracy of your bipolar classification compared to the unipolar?
Yeah, sir. At the initial part, it was a question for me also. But by seeing the results and by like analyzing all the results at each step, we have seen that it wasn't affecting this. In general, it should affect, but as we saw by breaking the results, it wasn't affecting much. But in case if it affects our result, we have different techniques like random oversampling, which can be performed onto this, which can definitely stabilize our data, and it can give equal number of samples for each class, but it was not
Thank,
required in this case.
great. Thank you very much.
Yeah,
Very
thank you, sir.
interesting.
Thank you, sir.
I think we can go for the next presentation if there is no question.
Yeah. So it is a design of an IoT-based smart home with audio sanitization system. Mohammed Sayed Uzamin
Yes,
is,
sir.
yeah,
Can you hear me?
please go ahead.
Okay, sir. I have requested for a pre-recorded video submission. Can I play it now?
Yes, go ahead.
Okay. Thank you, sir.
You have 12 minutes.
Okay.
I think, Sayed, we are not able to hear your audio. If it is recorded audio, we are not able to hear it.
Sir,
I think when you share, you have to click share with audio. When you say share, there must be a little tick somewhere. Share with audio.
You can reshare it once
oh,
I'll
sorry, sir.
share it.
I didn't see it. So can you hear it now?
Worldwide. Our presentation topic is on a design of an
Yeah, go ahead, please. Now it's
IoT-based smart home with auto-sanitization system. This presentation is presented by the authors of paper ID 112. Here is the author list. Firstly, I am Mohammad Saduzaman, the author of this paper, and the co-authors are Mohammad Samiul Islam Borno, Mohammad Hasibul Islam, and Shujan Hawladar. Here are the presentation topics. Introduction, smart home. What is an IoT-based smart home? Its working principle, auto sanitization system and its working method and working diagram. IoT-based smart home with auto sanitization system, schematic diagram and engineering diagram, and visual representation of the design prototype. Next, the application, advantages, social impacts, environmental impacts, novelty of the prototype, proposed business model, and conclusion. Introduction. Modern life and technology are deeply intertwined with one another. As recent scientific discoveries have drastically altered people's lives, the modern period is the age of science. The Internet of Things is the interlacing of devices by using the Internet. IoT carries out logical operations through which it transmits data and stores the same in the cloud. On 11 March 2020, the World Health Organization (WHO) announced that COVID-19 was a pandemic. COVID-19, which covers 219 countries, has infected more than 26.5 million individuals around the world. As time passed, the rate of coronavirus transmission decreased, but it increased dramatically after a couple of weeks, and it turned into a risk factor for well-being. In this situation, automated technologies such as auto-sanitization system may significantly impact society in crises like this. Technology for auto-sanitization may reduce the pandemic situation and create a health safety for well-being. IoT-based smart home. The biggest theme in IoT today is the installation of smart homes. A smart home features automation, multifunctionality, adaptability, interactivity, and performance. This IoT-based smart home focuses on building a wireless home security system which sends alert to the owner, controllable from anywhere from phone via internet, making it cost efficient for all the people. The concept of IoT-based smart home is to make it smarter, easier, and more efficient, a smart wireless home security device, and make it more comfortable and controllable. The IoT-based smart home is a system that connects every device via the internet with embedded electronics devices, such as Node MCU pairs Node with MCU microcontroller unit with built-in Wi-Fi integrated circuit and Arduino. Each unit has sensors and Wi-Fi connectivity so that you can track them with a smart device at home or miles away, which makes it easier to put on lights, lock the front door, or even turn the AC off anywhere you are. The working principle of the IoT smart home. This prototype can be accessed both remotely and by using voice commands. For remote access, the device requires a smartphone with an internet connection, and the Blink application has to be pre-installed. Switches to enable or disable connected devices are available in Blink application. Blink application sent a signal to Node MCU, which controls the relay to turn on or disable the desired device by pressing the switch available in Blink application. For voice command access, using Google Assistant on a smartphone, the voice command OK Google turn on light is given, and a control signal has sent via webhook to IFTTT. IFTTT sends an alert to the Blink application. The Blink application then sent Node MCU a signal to control the relay to switch the desired device on and vice versa. Auto-sanitization system. Auto-sanitization is a strategy that cleans our homes by evaporating fog. An antiseptic liquid evaporates at a basic level over a predefined coded time to disinfect the house's inner surface. To evaporate the fog, a disinfection fog machine had designed. The disinfection fog machine annihilates the infection by eliminating molds and microorganisms, gradually separating their synthetic structure and keeping them from basic oxygen before they can spread. Working method. There are four ultrasonic 113 kHz mist or fog creator in each disinfection fog machine that vibrates at a high frequency and heats the antiseptic liquids to make fogs, which operates at 5 volt DC. There is also a brushless fan of 5 volt DC that can evaporate the fog into the atmosphere. It works by creating a fog that surrounds the whole house with non-alcoholic and non-flammable purified antiseptic fluids. Thus, the fog spread all over the home and clean the inner surface of the home environment. A disinfected fog machine uses a hydrogen disinfectant or a hydrogen peroxide based disinfectant or sterile substance for vanishing purposes. The figure of a disinfection fog machine and the working diagram has shown besides. In the working diagram, we can see that 5 volt brushless fan had used to evaporate the fog to the atmosphere, and there is a antiseptic liquid inlet for letting the liquid inside the disinfected fog machine, and we can see there are four ultrasonic mist creator which is connected in parallel. An IoT-based smart home and the sanitization system had merged with Node MCU and Arduino Uno to make this prototype automated. The core stage of the research is implementation. For implementation, a schematic diagram was drawn at first, hence the hardware. NodeMCU had used for mobile wireless control worldwide since it has one integrated Wi-Fi system, and Arduino Uno programming had done with the Arduino IDE. Arduino IDE has done the programming for NodeMCU and Arduino Uno. Proteus 8 has used to design the schematic diagram. Here is the schematic diagram of the prototype. Here is the engineering diagram of the prototype. And this is the visual representation of the design prototype. Applications. A design of an IoT-based smart home with auto-sanitization system would have a remarkable effect on society in current pandemic situation. It can be a role model in reducing COVID-19 pandemic by creating a healthy atmosphere inside the surface of the house at a very low cost. This prototype could be implemented in classrooms, colleges, universities, workplaces, hospitals, and vehicles like cars, buses, etc., for creating a healthier environment and handle home equipment with health protection during this pandemic. It makes life more easier. Advantages. The sanitization system can be operated automatically when required. The disinfection fog machine's operation time can be changed as per consumer's need. Social impact. This prototype will help reducing the pandemic epidemic situation, exchange of economies, eliminate unemployment by establishing a new workplace. This prototype is long-lasting and cost-effective, better solution to social life, both comfortable and modern. The environmental impacts. There are no harmful radiation. It's a clean and green energy source, no risk of natural disaster, safe technology, non-flammable and non-alcoholic liquid, make it more attractive to the consumers, and it is also a food-graded antiseptic liquid, which do not harm our food. The novelty of this prototype. It's a low installation cost, zero emission and eco-friendly. It's a cost-effective and accessible for all people, use less electricity and less waste, creates a healthy atmosphere, track our property and control our smart home during work, holidays, or wherever we need to be. The smart home technology will provide peace of mind for children, aging parents, or disabled family members in their care. Proposed business model. This prototype can be also used as a business model as it can reduce the risk factor in this current epidemic situation of COVID-19, operates automatically, low installation cost, and the antiseptic liquid will need to be refilled. The cost equation. The cost effect from the table can be expressed from the given equation, where x is the cost factor and n equals to the number of products. Here x is positive, which means it is an profitable business prototype. If the number of product increases, the profit amount would also increases. If the number of product is 10, then the profit would be 15,000. The profit analysis shows that the profit is upward trend, which means a successful business, and it would be available for all to consume a healthy and safer life in future aspects in conditions like COVID-19. Conclusion. Today's world has a considerable demand for automation. Long-term but still no ideal vaccine is given to many individuals suffering from corona epidemic COVID-19. So we made a solution to reduce the corona pandemic that could be more effective. This prototype would also open up a new horizon for the electrical, electronics, and automated industries. Thank you for giving us a platform to share our research at 6th SMARTCOM 2021 conference. Any questions?
Any questions from the audience? Let me just check the chat if there is any question in the chat. No, I don't see any question. I have one question to start with, if you don't mind.
Okay, sorry, you can.
It's very interesting actually, and it's contemporary considering this COVID. What I have in mind is I saw Node MCU and Arduino. So are you using
Yes, sir.
both together, and why you
Yes,
need
sir.
to put two?
We are using both because Node MCU has only one analog port. So for using sensors, so we need an analog pin. So we use the Node Arduino Uno for the sensors, and for other purposes, we use the Arduino the Node MCU.
Okay, so for the programming part, Node MCU,
Yes, sir.
for the analog ports and ADCs and other things,
Yeah,
maybe.
we can do it with Node 16 to 1 maybe analog multiplexer, but we didn't get it because of the corona pandemic in our country. There was a lockdown, so we couldn't do it furthermore.
Okay, yeah, that explains. And the other thing is, at the moment, it seems the machine is stationary, so you have to put your machine somewhere in the room or install it.
Yes, sir.
Would it actually?
In our paper, we have attached the visual representation where we use the device as used in many portions in a room, which actually evaporates the fog into um, how can I explain, sir? Like in different ways. Like we used in like four or five places. From there, small fog uh, evaporates after like uh, 1 hour or 2 hour. Uh, Predefined time have used here, sir.
Okay, yeah. I was thinking that if the machine, your prototype, had some sensing capability, whether the person is there in the room or if the density of the fog is already there, then you don't need to spray it
Yes,
again.
sir. Yes, sir.
Then I
Yes,
think it would be more effective. But very,
yes,
very interesting.
yes, sir. Thank you, sir.
Thank you. I don't see any questions from the audience, so maybe if there is no question, we can move to the next presentation.
Thank you, sir.
So thank you, Sayed. And the next presentation, I think Wong is already here. So
Hello, everyone.
yeah, go ahead. You have 12 minutes, right? Thank you.
Okay. My topic is the strawberry maturity classification based on BP neural network. There are three main steps. First is image data pre-processing. Second one is the traumatic feature of the strawberry. And then is the BP neural network. In nowadays, with the continuous of the population growth, we need to improve the food production efficiency and also the labor cost. Now the AI already go into our life, like transport, like AI home, smartphone. Humans rely on their agriculture. Now we are trying to improve the agriculture more efficient. There are various techniques and systems are developed for the fruit harvest, like fruit detection, maturity estimation, localization. They play key roles in the harvest. There are many studies of fruit recognition based on the color space. In our paper, we study the vision navigation. Is a BP neural network employed with HSI characters and the red proportion to improve the recognition rate. The first step, we are trying to split the image into RGB channels, and the noise will be removed in each channel. In each channel is enhanced with CLAHE. It's contrast limited adaptive histogram equalization. After the image enhanced, after the channel merging, we get the enhanced image. This is a flowchart about how can we get the enhanced image. The image segmentation we achieved in the grab cut. These two pictures showed the input image and the segmented image. See, in picture B, we can see the image is removed from the complex collector. The second part, we get the traumatic feature. This is the result we get from the MATLAB. From A to B, from A to C is the picture from amateur strawberry, almost mature strawberry. C is matched strawberry. D to F is the unmatched strawberry RGB histogram. G to I is the almost matched strawberry RGB histogram. J to I is the matched strawberry RGB histogram. M to N is the hue histogram of A to C. From the picture, from the result, we can see only based on the RGB histogram, it's not easy to get to find out which is matched strawberry. But based on the hue histogram, it is more separatable than only on the RGB component histogram. From the above studies, we can see the hue is a very important features to choose which one is maturity strawberry, because it has more separatable features to classification. The mean and the variance value of the H component are extracted as the input data of the machine learning classifier. In table 1, we take 20 images to study and show the mean value and the variance value. Based on the table 1, we can see they are more unmatched strawberry, almost matched strawberry, they are significant difference between each other. And the third part is the red proportion. We can see the red strawberry is the matched one, but we studied the experience from the professional farmer. The red ratio is lower than 75 is unmatched. The red area ratio is greater than 90 is matched strawberry. Others between them is almost matched. This is red proportion ratios shown in the table 2. Every level, every degree of the matched, we take the maximum and the minimum red area to study. We can, based on this result, we can get the matched strawberry ratio. When we get the results from the last 2 steps, we can put the data into BP neural network for training. There are 3 input and 3 output, 6 hidden layers in this neural network. And the weight V and W can be got from the training process. There are 18 weights and 18 weights V, 18 weights W. The input layers are meaning the mean of hue, variance of hue, and the red proportion of the strawberry. And the output, they are ripped strawberry, almost ripped strawberry, unripped strawberry. This equation, we can get how many neurons we in the hidden layer, because we take NPQ. They are 3. They are 3 for input layer, hidden layer, and output layer. We know N and Q are 3 because it's input layer, output layer. And in this study, the alpha we taking 3, so we can get the neural network hidden layer is 6. The machine learning algorithm, we use X, H, Y. The X is for the input vector of input layer. H, I, and H, O are the input and output vectors for the hidden layer. Y and Y, O are the input and output vectors for the output layers. And the input and the output of each neuron in the hidden layer and the output layer are shown in the equation second. Because between the target output and the actual output, there are some errors, some difference. Based on the errors we calculate, we can update the result, update the equation 4 and 6 to get the new result. Put the data in the neural network training again. In this proposed method, we resize the pixel we resize the image to 255 and 255 pixels. Because some embedded system, they don't have the graphic card or GPU in it. So when the computation load happen, the training will be slow, take time. So to reduce the computation load, we segmented the image, shrunk to 3 numerical values: mean value, variance value, and the red array proportion. This is a result we get. We take the 50 images to be considered, to be studied. We can see when we after the 189 epochs, we can get the best performance. The statistic of the recognition result. We take the from the table 3, we can see we take the 50 images, and the correct show us the correct images, the array images, and accuracy show the result. Compare with the state-of-the-art method, we can see the proposed method is 96%. In this study, we use the BP neural network based on the color features. Also, the result also compared with the state-of-the-art method, the accurate is 96. In the future study, to improve the rate of the recognition, we are going to consider about the obstacles, make the training BP neural network more strong to recognize the images. So will help the agriculture to improve the efficiency. Thank you.
Thank you. Very interesting presentation. Any questions from the participants? You may raise hand if there is any question from the participants, or put it in the chat, or just take the microphone and ask. I can't see any questions in the chat or hand raised up, but I have one question for you. It looks like from the presentation and the way you describe, you use a single strawberry and the embedded systems, because you mentioned 256 by 256, so low processing devices. Are you considering putting sort of a strawberry one by one on the conveyor belt, and you just take the picture of one strawberry at a time and then check whether it is mature or not? Or is it a camera and it takes the picture of lots of strawberries and then you process it? What's the methodology?
Okay, we take a lot of strawberries to be training in the neural network. So so we will get the more good results, because if we take more strawberries, and we will get more data from the different strawberries, a different feature between the different strawberries.
Yeah, I understand that that you have lots of training for this, but when you take the data, raw data, for example, how you implement this algorithm as a real-time or embedded system? Is it sort of an assembly line? Are the strawberries going one by one on the conveyor belt, and from the camera you take the picture? If the strawberry is mature, you keep it. If it is not mature, then you remove it. Is it something like that?
Yes, if it is matured, we will take it. If it not matured, we will move to the next one.
Okay, okay. Thank you very much.
Thank you.
So I think there is no question. Maybe, thank you. We can move on to the next presentation.
Good morning, sir.
Yes, so the next presenter is ready.
Yes, sir. Shall I share my screen?
Yes, please.
So shall we begin?
Yes, you have 12 minutes.
Okay, sir. Good morning. A warm welcome to one and all present here. Myself, Hdhcd, one of the authors of the paper, Intervention for Improvement of Water Quality in Rural Village in Rajasthan, would like to present this paper on behalf of all authors. The outline of the presentation will begin with introduction, followed by methodology, results, conclusion, and the acknowledgements. To begin with introduction, water is one of the most essential factors for sustenance of life. Out of the total water resource available, only 3% of the water is fresh water, whereas remaining 97% of the water is unfit for drinking. Out of this 3%, only 69% is available in glaciers, 30% in groundwater, and less than 1% in lakes and swamps. In India, Rajasthan holds the first position in water scarcity and impurity. This paper presents a case study of water impure region, Shamoli. This research was done as a part of Living Labs program of Amrita Vishwa Vidyapeetham. Shamoli village is located in Savai Madhopur district of Rajasthan. According to primary data, the total population of the village is 462 and the number of houses in the village is 126. Through investigation, we inferred that water impurity is a major hurdle faced by the villagers. Methodology. An ethnographic approach has helped the researchers to understand the Shamoli village. Participatory rural appraisal and human-centric design approaches were adopted to understand deeper about the community. Interviews and group meetings were also conducted based on the questions related to sources, challenges, and awareness about government schemes and subsidiaries available. Participatory rural appraisal. Participatory rural appraisal was conducted to gather the first-hand knowledge about the resources, socio-economic situations, and hurdles faced by the community members. PRA also helps in selecting the most prevalent challenge in the village. The tools of PRA are resource mapping, inflow-outflow diagram, seasons and activities, brainstorming, and the problem tree. Resource mapping. Resources specific to thematic areas such as agriculture, water, health, education, and many other parameters were mapped. Inflow outflow diagram. The resources that are bought into and taken out of the village are considered. Seasons and activities. The activities performed during the entire different seasons of an year, the data was collected. Brainstorming. Discussions were conducted among the participants that consists of one person from each household. The problem tree. This tool guides in analyzing the cause and effect of the challenge identified and also helps in deducing the most prevalent problem from a set of identified problems. To further understand the impact of identified challenge on the community through the experiences, human-centric design was used in the study. Human-centric design was conducted ensuring users as the participants of the design process. In order to effectively implement HCD, tools such as participant observation, semi-structured interviews were used on which personas and scenarios were developed. Participant observation. Observation of the participants are done using this method. To make it more focused, we used AEIOU framework. AEIOU framework, through this which we are able to concentrate on activities, environment, interactions, objects, and the users. To get more insights on the users, their needs and the pain points, observations were augmented by semi-structured interviews. Interviews. The semi-structured interviews were conducted to gather qualitative as well as quantitative data. Qualitative data like goals, tasks, and the pain points, and quantitative data like occupations, amount of land for cultivation, water consumption for household, etc. were collected. Personas. To further understand the demography of users, personas are created from the interviews. It plays a major role in identifying the pain points. Scenarios. This describes briefly about the hurdles faced by the villagers during their day-to-day activities. It also focuses on major challenge with which villagers needs assistance. Results. Based on the tools used in methodology and from interviews, qualitative data like source of drinking water, water for irrigation, and other water consumption sources are collected. Apart from this, we also observe the source of electric power supply and type of shelter in which people live. A resource map is drawn based on these observations, and the resource map is represented as shown. Seasons and activities. We inferred from seasons and activities, due to shortage of water, the agriculture has been carried only during the winter and rainy seasons as represented in the table. Inflow-outflow diagram. Referring to the interviews conducted with one person from each family, we have inferred that they preserve crops for some quantity for themselves and sell rest of the quantity for generating income. The inflow-outflow table is shown as below. From the brainstorming session with the villagers, we understood that the major problem faced by the people is non-availability of drinking water. These are the results from PRA section. Moving to results from HCD section, beginning with participant observation and the water samples test. People frequently fetch water from two hand pumps for drinking and washing purposes. The water samples from the two hand pumps are collected and tested as per standard drinking water parameter limits. The standards are IS 10500 2012 standards. Interviews. Qualitative data such as amount of water consumption, number of people per household were collected from interviews. The data was analyzed and maximum drinking water was found to be around 9 liters per person. A graph was plotted based on water consumption data, number of people, and their house numbers. Personas and scenarios. From interviews, personas were created to understand major pain points. We found that they don't have schools in the village, lack health facilities, and has to travel long distance to fetch water. The water they drink is salty. These are the pain points put forth by them. After going through the results, we understood that a sustainable water purification system with a smart utility network, which can actively monitor and dynamically optimize the system, is required to better serve the community for resolving this problem. Results 2. The major parameter, the section discusses about the two best suited methods to reduce the difficulties faced by villagers with drinking water. The major water parameter limits that are above the permissible limits are TDS, chloride content, calcium, and magnesium. The two methods were suggested to reduce the difficulties faced by the villagers. Method 1 is integrating reverse osmosis with Jivamritam water purification system. The Jivamritam purification system has a layer of activated carbon followed by 4 layers of sand filtration. This also has 5 micron and 1 micron filters followed by UV light for disinfection. Method 2, humidification and dehumidification system. The flow chart shows the process to filter the impure water. It begins with pumping the bore water to the coagulation and sedimentation tank. The coagulants are added based on particular ratios to partially convert the hard water into soft water. The mixtures in the coagulation tanks mix the fluid with coagulants to form sludge and pure water. Sludge is removed by sedimentation and partially filled water is sent into semi-filtered tank. Here, semi-filtered chamber is sent into Jivamritam filter, followed by reverse osmosis. This is about method 1. Or the semi-filtered water can be purified using humidification and dehumidification process. Conclusion. By implementing the PRA method in the village, we gathered the first-hand knowledge about the available resources, socio-economic situations, and hurdles faced by the villagers. Through HCD approach, we understood the pain points with reference to scenarios, personas, and identifying the main challenging area of the village. Understanding the basic need of community is purified water. Two methods for water purification systems are suggested in this paper. One of the method is an extension of Jivamritam filter with RO, and other is a HDH system to provide a clean drinking water. Further research using co-design will develop one of the solutions with the community. Acknowledgements. This research was funded by Amrita Vishwa Vidyapeetham Living Labs program, and the field implementation was funded by UN-recognized NGO Mata Amritanandamayi Mat. This study was done as a part of UNESCO Chair for Experiential Learning for Sustainable Innovation Development. The authors express their immense gratitude to Sri Mata Amritanandamayi Devi, Chancellor of Amrita Vishwa Vidyapeetham, who has inspired them in performing selfless service to the society. We would like to express our sincere appreciation to Mr. Gopi Iyengar Sheshadri for his extensive support in enhancing the quality of paper within the limited time frame. The authors also thank government officials of District of Savai Madhopur, Rajasthan, and the staff of Amrita Self-Reliant Villages. Thank you.
Thank you, Mr. Reddy. This was really interesting, very pertinent to the community and the society, and multidisciplinary, involving the information systems management in engineering and sociology as well. Any questions from the participants? I can't see any raised hands or chat. I had just one question, if I may.
Yes, sir.
For your presentation, I think this is very nice. You have looked into various management and strategic concept. Is this model that you develop can be translated into some kind of a tool or a software or information system that can be implemented or used again and again in such scenarios? Is there a possibility?
Yes, sir. Yes, sir. If there is a situation where the parameters are exceeding the limits, we can use this particular methodology.
Great. Thank you. Thank you very much.
Thank you, sir.
So I think if there is no question from the participants, we can move on to the next presentation, please. So the next presentation, Islam here.
Yes, sir. MD Islam, sir.
Okay. So would you like to start your presentation? You have
Uh,
12 minutes.
yes, sir. Sir, I would like to play the pre-recorded video.
Yes, just make sure that you tick this audio when you share that, otherwise audio would not play.
Yes, sir. Welcome. Sir, is my screen visible, sir?
Yes, screen is visible.
Sir. Welcome everybody to 5th International Conference on SMARTCOM 2021. Sir, sir, is sound audible, sir?
Yes.
Oh, thank you, sir. Las Vegas. Welcome everybody to 5th International Conference on SMARTCOM 2021, Las Vegas, Nevada, United States. The title of our project is IoT-based Smart Street Light for Improved Road Safety. The paper ID is 143. The authors are MD Hasibul Islam, Khadija Yasmin Faria, MD Taslim Hussain Tanim, Thoidul Islam Talukdar, and Nafiz Ahmed Sisti. Department of Electrical and Electronics Engineering, American International University, Bangladesh. The contents of these presentations are introduction, goal of the project, features of the project, novelty of work, block diagram, required components, simulation, project demonstration, result analysis, advantages, future developments, and limitations, reference. In this modern era, street lights are using in every smart city all around the world. Analog system or a hand operated system are used for controlling purpose of the street light. Generally, the street lights are designed with high intensity lamps, and they cannot be changed as per the requirements. As a result, they are consuming a lot of energy. On the other hand, road accidents occur due to the increase in traffic, or rash driving on highways, and unconsciousness. In this situation, people are moving automation technology that can make life easier. Many investigators have created a number of automated systems in recent years. There are many automated systems that work in an efficient way, but not a single system has been found that addresses all the issues at a time. Now I am going to literature review section. In 2018, Piaget implemented a smart street light system. He used Arduino Uno as a microcontroller in his project, and the system was able to control the street light concerning pedestrian and vehicle movement. In 2020, Rajvardhan Rishi implemented a vehicle tracking and accident detection system. He identified the accident with the help of accelerometer. He also used Arduino Uno as a microcontroller in his project. On the other hand, in 2080, Nagarjuna Arbati implemented a smart road accident detection with communication system. This system was used to inform the nearest hospitals and police along with the location of the accident. He added airbag and anti-lock braking system for safety purposes. In 2019, Muhammad Abdul Qadir suggested IoT-based vehicle monitoring system. He added emergency push button or panic button in his project. If someone presses the emergency push button, it sends the SMS to the proper authority with the exact location. Goals of the project. Nowadays, streetlights are using hand operated system. As a result, they are consuming a lot of energy. And also, the road accidents are increasing day by day. The main goal of our project was to establish a street light system that will control the intensity automatically, and a sonar sensor based road safety system that will notify the authority in any unusual situation. The other goals of our project to reduce the risk on the street, because when someone presses the emergency push button, the authority will be informed. To minimize the death rate, on the street and it will help to take immediate action and reduce the loss of energy because we are using the solar power as a power source of this prototype. The features of the project are automated intensity control, manual control system, and solar power will be used as a power source, accident detection with car name plate detection, and emergency push button with face recognition system. As we didn't get any single system that addresses all the issue at a time, so the novelty of works are accident detection system instead of implementing any device inside the vehicles. Combination of multiple features regarding road safety. The system can be monitored from the control room and can be controlled remotely. The emergency push button is another remarkable features of this project. Block diagram for street light. In this slide, there are two block diagrams. The first block diagram indicates the control method of street lights. We have used Blink app as a mobile application, and this mobile application is connected to the Blink Cloud server, and street lights are also connected to the Blink Cloud server through the Node MCU. And figure 3 indicates the LDR sensor data to the ThinkSpeak server. LDR sensor reads the data and it sends the data to the Things Cloud server, and the authority can see the data through the computer, and the computer and the LDR sensor are also connected to the ThinkSpeak Cloud server. Block diagram for accident detection system with nameplate detection system. There are two figure 4 and figure 5. In figure 4, ultrasonic sensor is used to detect the car appearance. When ultrasonic sensor detects the car accident and it directly sends the data to the Things Cloud server, and the authority can see the notification through the computer. And when the ultrasonic sensor detects the car accident and the system is ready for image processing or the nameplate detection system, and this process is shown in figure 5. Block diagram for emergency push button with face recognition system. Figure 6 indicates the push button system. Push button is connected to the Node MCU, and Node MCU is connected to the Blink Cloud server. We have used Blink app as a mobile application. So when someone presses the push button, the signal goes directly to the Blink Cloud server, and from the Blink Cloud server, the signal comes mobile application, and as a result, the authority will be informed. When someone presses the push button and the system is ready for a face recognition system, and this process is shown in the figure 7. In this slide, the panelized block diagram has been shown. Solar power is used as a power source, battery is used to store the charge, and voltage sensor is used to measure the voltage of the branch. So there are two Node MCU. In Node MCU 1, emergency push button is connected, LDR sensors are connected, and face recognition will be done in Node MCU 1. And in Node MCU 2, the ultrasonic sensors are connected, LDR sensors are connected, and nameplate detection will be done in Node MCU 2. So Node MCU 1 and Node MCU 2 both are connected with the cloud server. As they are connected to the cloud server, the authority can control remotely, and also the authority can see the data through the computer. The required components are shown in this slide. Simulation for automatic streetlight system and car accident detection system. Figure 9 shows the automatic streetlight system and figure 10 shows the car accident detection system. So in figure 9, a LDR sensor is connected with analog pin, and 4 LED with 4 resistors are connected with D0, D1, D2 and D3, and 2 emergency push buttons are connected with D7 and D8. On the other hand, in figure 10, 2 ultrasonic sensors are connected with Node MCU2. Project demonstration for street light, emergency push button and car accident detection system. Figure 11 shows the street light circuit including emergency push button based on Node MCU. There are two street light 1 and street light 2. A LDR is used and it is connected with Node MCU 1, and two emergency push buttons are connected with Node MCU 1. On the other hand, figure 12 shows the accident detection system, and two ultrasonic sensors are connected with Node MCU 2. In this slide, the finalized demonstration of project prototype model has been shown. There are two Node MCU, two ultrasonic sensor, one voltage sensor, a camera, two street fall, two emergency push button, LDR sensor, solar panel, and battery, and MPPT controller. Result analysis for auto intensity control state light. Figure 14 shows the auto intensity control state light. In figure 14, there are no any ambient light. As a result, the LDR sensor turn on the state light. At the same time, the LDR status on the web server has turned on its notification, and it is shown on the figure 15. And when there are ambient light and the LDR status turn off, and it has been shown on figure 16. Result analysis for manual control of listed light has been shown in this slide. We have used blink application, which is shown in figure 18, and we can turn on the stored light by manually, and we can also increase the intensity or decrease the intensity that is shown in figure 19. So in figure 17, it has been shown that manual control of stored light both switch on with low intensity. When we decreases the intensity from the blink application, the light also decreases the intensity. That means the whole systems are done with manually. Car accident detection system with nameplate detection. In figure 20, we can see that a accident has been occurred. If a car remains at the exact position during the 15 seconds, the ultrasonic sensor will send the data to the web server. And that has been shown in figure 21 and figure 22. And at the same time, the authority will be able to see the accident, and they can capture the image and identify the nameplate. Emergency push button with face recognition system has been done in this slide. In any unusual situation or in any danger or in when a harassment occurs, in that situation, if someone presses the emergency push button, it will create a signal, and the signal directly goes to the authority room through the blink application, and that has been shown in figure 24. And in this situation, the authority will be able to detect the face by facial recognition, and that have been shown in figure 25 and figure 26. Location detection and voltage indicator. Figure 27 shows the location detection. Figure 28 shows the voltage sensor circuit. The voltage sensor circuit will measure the voltage, and it directly and it pass the data to the web server, and the authority will be able to see the data from the web server. That has been shown in figure 29. And figure 30, it will express the voltage in numerical way. Advantages of the project: manual control of the street light can be avoided. It is lower energy consuming system, and the injured people from accident can get help immediately. The system can be monitored from anywhere. Nameplate of any vehicle can be tracked easily. Distinguished features like emergency push button. Future developments and limitation. The future developments are artificial intelligence can be added to detect the accidents accurately. Private cloud server can be made, and multiple energy sources can be added to this system. Over speed tracking system can be added in this feature in this project, and private mobile application can be made. And the limitations are this system power outage at the time of bad weather. Too much traffic can cause the false alert, and regular maintenance of the sensor is needed. This is the reference. Thank you, everybody. So, do you have any question? You can ask me.
Thank you very much for your presentation. It was
Thank you, sir.
uh, quite a number of systems are integrated, and a very nice prototype, very impressive. Any questions from participants? I see there were a few IoT-based presentation. Anybody who has worked in IoT would like to ask any question? No? Okay, so I have just one question for you. In your diagram, you mentioned two things, blink and think speak. So why do you
Yes,
need
sir.
both? And what are the specific things that you can't do with one of these services?
Sir, Blink, we have used Blink application for controlling purpose. It is easy to use because we can remotely control the system with the help of Blink application. On the other hand, if we want to control the whole system with the help of ThinkSpeak Cloud Server, then it will take a lot of time. And here we have used blink application, and we can get the signal from the emergency push button. Almost it will take less than 1 second, and this is the unique portion of this section.
So is it mainly for MATLAB related tasks like image processing you are considering things, Nick?
No, sir. We have
Okay.
used, sir. We have used Python, OpenCV, sir, and we are trying to solve this prototype with the help of artificial intelligence, and we will do in future.
Okay. And in your case, you have two nodes, N1 and N2, two node MCUs.
Yes, sir.
Are they communicating with each other directly or through cloud?
Sir, they're connected with the cloud server.
Okay. But there is no communication between them
Uh,
as such.
yes, sir. Because sir, we can use one node MCU, but as one node MCU has only one analog pin, and that's the main reason to use the two node MCU.
Okay. Yeah. Great. Thank you very much.
You're most welcome, sir.
So I don't see any other questions in the chat or raise hands. So maybe we can move to the next presentation. Okay. Mohammed Aslam here.
Yes, sir. Can you hear me?
Yes, I can hear you. Would you like to start?
Yes, sir. Just a
Yeah,
minute.
you have 12
Just
minutes.
share my screen. So, can you see my screen?
Yes.
Good evening, everyone. Mohammed Aslam is my name. I'm currently pursuing my information technology cybersecurity degree at Hindustan University. Our title of our paper is Analyzing and Identifying Harm Propagation of Cyber Threats in Autonomous Vehicles and Mitigation through AMN. So the authors are Saranmani Sharmila V, Mohammed Aslam H, and Mohammed Rizwan M. So abstract of our project is CAVs in autonomous vehicle is fostering developments in new technologies such as AI, ML, and IoT big data. They rely on variety of electronic sensors and computer systems, which makes them vulnerable. They require strong security mitigations to ensure that these systems work reliable and reduce risk. We analyze the various cybersecurity vulnerabilities and threats which are possible in AVs, and we have proposed a mitigation for a model by observing the harm propagation of cyber threats. So vehicles are now built with increasing level of automation. The technologies embedded in CAVs increases the vulnerability. These led to illegal access of vehicles through various attack surfaces in the vehicles. So our project is mainly of two parts. The first part consists of the research analysis which we have made, and the second part is the mitigation model we propose. We have done a literature survey for nearly 5 papers. In the first paper is the cybersecurity attacks in vehicular sensors. Uh, what they did is they concentrated only on the sensing layers of the vehicles, like GPS and vehicle dynamic sensors. They have used two methods. They shield sensor ID from the attacks from the sensors and mitigate the spoofing attacks on antenna. So in next, security threats for autonomous and remotely controlled vehicles in smart city, they use the DIVA integrity model. They they group the data into the data and subset and with the level of the integrity. So next, towards artificial intelligence-based cybersecurity for robustifying automated driving system against camera sensor attacks. They they concentrated only on the camera sensor attacks and what are the possible mitigations they have used and they propose. A test-driven approach for security designs of automated vehicles. By using the data visualization tools before the designing phase, they try to implement a mitigation solution for the specified attacks. So in this paper, they use the authenticated key management protocol to depict some of the attack and simulate the attacks and try to mitigate them. So in that, this is the first part of a project analysis. These are the 18 most common attacks. The next part of the attack is the generating a harm propagation tree. Propagation means to cause to spread out and affect a greatness of area. The thickness of each gives us the weight and harm of the attack. This attack is based on the impact of the every attack. This tree is based on the impact of the attack. So each attack refers to some of the focuses on some of the attack surfaces which makes them the most vulnerable. Different color represents the various cyber attacks on CAVs. Thicker the edge, the threat is considered more harmful. So same harm propagation tree is drawn for attack surfaces. It depicts the attack which focuses most of the attack surfaces on CAVs. So this is the second part of our analysis, connected dominating sets. So CDS in a graph are the nodes in which all the nodes can be covered by these nodes. For example, if we take this figure A, B, C, D, E, B and C are considered to be the CDS nodes. With the help of these nodes, all other nodes can be traversed. So similarly, by taking these nodes are the attacks, by finding the CDS nodes of the attack of the graph, we can find the most harmful attacks of the graph. So similarly, the same graph is drawn for attack surface. In this attack surface, we found only the 7 most common attack or most harmful attack which exist in CAVs. So in this analysis, after the furthermore analysis, we have found that GPS is most targeted attacks on CAVs. So we have tried and proposed a mitigation solution using the artificial neural networks. Artificial neural network consists of 3 layers. In the input layers, all the data sets are processed, and in the hidden layers, the data sets are processed by 3 layers. In the first layer, the data are processed in form of hundreds, and the second layer in 200, and in third layer 300, and so on. So the artificial neural network process all this data from our data set and predict the output, whether the GPS is compromised or not. So when we have used around 5 lakh data to as an input of our artificial neural network. We had a validation and training accuracy of more than 95%, which gain us a more suitable thing for our project. We have compared the same algorithm with another algorithm of support vector machine. The accuracy was below 75%, and also the results weren't accurate. For example, in this we can see the confusion matrix, where in the confusion matrix there is 4 parts: true positive, true negative, false positive, and false negative. In true positive, where the machine predicted true, where it has to be true, and in the true negative, the machine predicted false, where it has to be true, and in the false positive, machine predicted false, where it has to be false, and in the false negative, it has to be false, but it printed true. So I try to conclude that we have analyzed the various attacks focused on the CAVs and implemented CDS, and we try to implemented CDS and try to mitigate a GPS attack so that our CAVs cannot be compromised. So, thank you, sir. Any question?
Thank you very much. Any question from participants? I don't see any raised hands, so I believe There is no questions. This is quite challenging problem. Autonomous vehicle in itself is a challenging problem, and
Yes.
so much work has been done. In terms of what do you think your next move, how you would improve, or where you will go from this research?
This research, we have proposed mitigation for only a single model GPS, while the autonomous vehicles have variety of sensors and there are many methods it can be compromised. So we are thinking to widen our research and try to provide a solution for every other attacks and we propose mitigation for the same.
Yeah, I think this is sensible. Thank you. Thank you very much for your
Thanks.
presentation and time.
Thank you, sir.
I think I will hand it over to Amit now. Probably all presentations are done, I guess.
Thank you, Dr. Shukla, for managing this whole session as a session chair, and we really appreciate your efforts. And I'll ask my team to showcase a token of appreciation to you, Dr. Shukla.
Thank you very much.
We will be
Thank you very
sending
much.
it through mail very soon. And thank you very much once again to all the authors for contributing. And I think Rajesh has some questions. His hand is up.
Yes, sir. Good evening, sir. Actually, I didn't finish my presentation.
Your session number is?
Yes, 268.
And your
session number, yes. After this, 5:45 is actually my session schedule, BST.
But is it in this presentation session?
Yes, sir. I'm following this the same.
No, sir. He is in 2B, sir.
Okay, no worries. I think 2B is over. So, Dr. Shukla, can we take this one more presentation if you have 10 more minutes? With you?
Yes, sir.
Can we take his presentation for 10 more minutes if we have time? Can we take Dr. Shukla?
Yes, sure. Why not?
So I think you can present your work. Rajesh, you can start presenting your work.
Yes, sir. I'm just trying to share the screen. Thank you, sir. Thank you for accepting. So very good evening to all. I hope the screen is visible. Am I audible, sir? Yes, sir. Thank you. Yes, sir. Thank you for giving an opportunity.
You have 10 minutes for the presentation.
Yes, sir. Quickly, I will go through this. So myself, I'm Rajesh. I'm pursuing my PhD in University College of Engineering, Usmania University. So I'm here to present an idea regarding my research. So a novel variant optimized search algorithm for nuclear cell detection in histopathology breast cancer images. So this histopathology is nothing but the study of tissues. So now it has become fully computerized. This pathologist will study those images under a microscope to predict the seriousness of cancer. So it became a very difficult task for them to predict the seriousness of a cancer because of that cell nucleus are very small, irregular, and contain some noise. So hence we propose some optimized segmentation method in order to recognize these cell nuclei. So for experimental analysis, we collected the data set from Breakhe's database, and then pre-processing normalization is done. Then once an image is enhanced, the iterative clustering algorithm is employed to find superpixels, and then this PSO and GWO search algorithm is employed to select some optimal cluster centroid. So main purpose of the system is to perform the segmentation and find some cluster centroid. The purpose is to find some optimized cluster centroid where some nuclear cell is present. So this proposed algorithm has given better results compared to the other previous work. So future we can have separate, we have observed some overlapping cells where it can affect the classification. So this we have done some methods. So quickly I will go through this review I have done, and this is the review on segmentation which I have done. Okay, so several authors they have proposed, they have used some convex edge grouping approach, same region of ROI, region of interest, and the CNN, and then IGSA algorithm, search algorithm they have used. Okay, so but due to some limitations, so we have proposed the methods first initially collected the data set, then normalization, then using an iterative cluster algorithm, then finding a clusters, then after finding the clusters, finding an optimized super pixel, then get the segmentation of the image. So this is the basic data set collected from P&D laboratory Brazil. So we have breakage data set which contain different magnification images, 400x, 200x, 100x, but we used only 400x magnification images because it focus on mainly on nuclear based segmentation. Other magnifications are very small which cannot be performed segmentation. So hence first we have done and pre-processing. Once images are collected, we done a pre-processing. So where this is what a formula which is used to normalize the image to enhance, okay, where the image by just changing the pixel intensity values by using this equation. Okay, so where ni is the normalized images, so I indicate some input image, that is histopathology image which we are using. Then the pixel intensity ranges will be changed, like suppose if the input image intensity is 50 to 150, so if we prepare the image, preferred image is range is 0 to 255, just simply subtracting that 50 from each pixel and make that pixel intensity range to 0 to 100. Okay. Then these are the sample normalized image. So normalized images, sample images and normalized images. Then we have employed this optimized superpixel segmentation. So we applied this algorithm to divide that given image into clusters, then find the optimal cluster center. By using this the simple approach, just it requires only the number of pixels you require and how many number of clusters k. So initializations, two steps will be done. First is initialization, then clustering. It's an iterative process where randomly we'll select using this equation like s is equal to root of n by k. N is nothing but number of pixels of a normalized image and k is number of clusters. This is what we got, the super pixel image where number of clusters have been formed. Then so PSO algorithm we have used. So this is a search based algorithm, optimized search space, and each there are some particle particle swarm optimizer, where it evaluates best particle comparing with this current position. Then it updates the current based on best position. It finds the best position based on the velocity. Okay, then global best and local best, it compares and it finds the position combining with the current position with one or more other swarms within the search space. Then GW is an algorithm which a gray wolf optimizer, both optimizer algorithm. So it finds, it calculates the fitness alpha, beta, gamma. There are some wolves, alpha, beta, and delta. So these are all gray wolves, named as gray wolves. So they will function using an iterative manner. It calculates the fitness value. Okay. So in this study, what we have done is we combine these two algorithms, optimization algorithm PSO and GWO, which are applied to identify cluster centroid. So these two algorithms are combined and obtain cluster centroid with minimum fitness value. The main advantage of this segmentation using this PSO and GWO algorithm is to decrease the input entities and compute more meaningful features. So this optimizer, this algorithm is we combined because algorithm at low level co-evolutionary, because these functionalities we combined because the functionalities of both variants at low level, to because we are running both these parallelly instead of one after the other. So these two algorithms are combined because they are two distinct variants and involves in generating final solutions of the problem. So because of this modification, we have improved the ability of exploitation in PSO with the ability of exploration in GWO. So both can produce both variants power. So after finding this cluster centers optimal cluster, to measure the optimal cluster centroid using this equation, the distance is calculated using this distance formula. Then Euclidean distance is used to find the distance between these two clusters. Then correspondingly spatial domain and color space, the distance measured will update to its nearest cluster by considering mean of all other pixels. This process will continue until this residual error is converged. So this is the images, like first input images, benign image and malignant images are collected from breakage data sets. Then normalization, contrast stretching is done. Then these are the optimized super pixel where iterative cluster method is used. Some clusters are identified. Then this is the main nuclear cells are identified. This is the segmentation image. So according to this iterative algorithm uses time complexity order of n, where n is nothing but number of pixels. Then based on this modification, PSO and GW algorithm modifies its position and the velocity. Both algorithms will modify this position and velocity. So therefore we use order of p square, which p indicates this population size. So hence the time complexity for this method is combining with all this iterative cluster algorithm, then fitness function, then PSO GWO. So it's order of n plus n into g plus p square. So this is the algorithm. Then this the results we performed on MATLAB 2008 using this process. Then performance examined using Dice and Jaccard coefficient. So initially 100 histology images are collected, like 50 malignant and 50 benign images. So in this paper we compared this with some methods like SAC and all other methods with these Jaccard and Dice coefficient. So these are the k-means clustering, FCM superpixel with PSO, superpixel with GWO individually, then later PS superpixel with PSO, GWO both combined, and we have seen and we have observed in combination with PSO and GWO, we achieved 87% of Jaccard coefficients in benign images and 93 in malignant images Dice coefficient. So this is the conclusion we came to. Main objective is to perform segmentation, so find a clustering centroid. So in this work it works effectively in separating nuclear and non-nuclear cells related to the previous work. So one limitation of this proposed work is like we observed overlapping of nuclear cells that may affect accuracy of classification. Hence we can perform in future, we can separate this overlapping cells of the from the segmented image as foreground on background by applying some threshold, so that the efficiency of the segmentation may increase, which can result in better classification. So these are the sample references. So thank you for giving an opportunity. Thank you, sir. Yes, sir. Hello. Yes, sir.
I
I'm
think
audible.
you are sorry, you are fine.
There's no question from the participants. I find this presentation very, very interesting. And I understand this is just a segmentation. So at the
Yes.
moment, you cannot really say anything about the classification or accuracy. Somebody has to use this and work out how well they would uh, work with the classification. But in terms of the complexity of the algorithm, what do you think? Computational complexity, how it will fare?
So we are, yes, sir. We are combining the time complexity of iterative clustering algorithm and uh, these two PSO, GSO, both we are combining, and we are getting an time complexity order of p square. So comparing with these other methods, we feel that time complexity is more. We are achieving better results for the segmentation. So, but for classification in future, we are going for classification after applying this thresholding. We are going for feature extraction, feature selection. Then we go for classification. So
Thank you.
I'm just presented only part of my research. So just only segmentation part I have presented.
Correct. Thank you.
Yes. Thank you, sir.
So thank you to you and all participants. All the papers are nice and they are in line with the smart systems, or in some way they are intellectually stimulating and very smart in systems algorithms in solving various and diverse problems. Thank you, Amit. Over to you.
Thank you. And before I think we close this session, because we have already presented a token of remembrance to Dr. Shukla, I would ask everyone to just on their screens with the camera so that we can just click a picture
Yep.
of everyone. So just flash up your screens.
Yep. Sure.
Whoever is available, please, I request you to flash up your screens. I think we will wait for 30 seconds so that everyone can settle down. And after that, we'll just stop it. I think, Harsh, you should take the snap of this.
Yes, sir.
Okay. I think 10 more seconds. Okay, thank you very much. And there are few notes for the authors that we have already submitted the data for publication to Springer, and it will take approximately 4 to 5 months for the complete processing. And in the meanwhile, whatever issues or whatever things we will get, we will directly divert it to you. And apart from it, you will also get a proof copy before the paper is published to be approved by the corresponding author. So thank you very much. And if you have any questions, any assistance you need, directly write to the support team, or you can directly write to me at amit@gr.foundation. I'll just chat my mail ID to everyone. If you have any questions at any point of time regarding this, please feel free to write to me as well. And thank you very much. Tomorrow again, session number 3A, 3B, 4A, 4B, and 5A, 5B will be there starting from 10 a.m. British summer time, and we will be closing this conference at around 5 p.m. That is British summer time. So another 6 sessions are awaited tomorrow. So I look forward to see you all at that sessions as well. The links are the same what we have for 1A and 1B. So A follows in a sequence 1A, 2A, 3A, 4A, 5A, and B follows in a sequence 1B, 2B, 3B, 4B, 5B. So if you want to attend, please do visit us. Thank you very much, and we look forward to see you tomorrow. Thank you, Dr. Shukla, once again for your support and your valuable time which you are spending on this evening. Thank you very much.
Pleasure.
Thank you.
Thank you, sir. Thank you all.
Thank you, sir. Thank
Bye.
you.